Welcome to this video presentation by the postgraduate student whose poster it represents. We will miss the bustling crowds around the posters at the All Energy Conference this year, but we hope you enjoyed this online version that we have created. Before the presentation starts, I would like to acknowledge the support of our generous sponsors. Without this support, the competition could not proceed and the winning entrants would not receive a financial award. Our platinum sponsor is the Victorian Government through the Department of Environment, Land, Water and Planning. Its brands include Victorian Energy Compare, Victorian Energy Saver, Victorian Energy Upgrade Program, Energy Scorecard and Energy for Business. Their contact details are on the slide. Monash University's Monash Energy Institute is one of our silver sponsors. With over 170 staff involved, the Institute has a vision to bring people together to solve global energy problems. The Monash student posters in this competition represent some of that work. BayWa Renewable Energy is another silver sponsor. BayWa develops both wind and solar projects in Australia as part of a global energy portfolio. BayWa staff have also supported our AIE events in the past, including our Young Energy Professionals Speed Networking events. Our final silver sponsor is the University of Melbourne's Melbourne Energy Institute. Many of you will have attended their regular forums that keep the energy community and public up to date on technical and policy energy matters, and the University of Melbourne posters in this competition reflect some of that work. Seed Advisory is our bronze sponsor, and this small but well-recognised energy consultancy covers both the technical and regulatory fields. Seed Advisory has been a regular supporter of the AIE and a presenter at our events. Lastly, we thank All Energy for hosting our live poster events over the last decade, and we look forward to doing this again post-COVID. These last slides show you our poster winners in the last competition. And I now hand you over to the poster presentation. Thank you.
Hello, I am Afa. I will be presenting today my poster, which is named Divide and Conquer, Large-Scale DR Orchestration and Using Distributed Optimization. This small network is here to show you the challenge that DR are bringing for distribution networks today. This is a high voltage feeder connected to 4 low voltage feeders, and almost all the houses has PV systems, which at midday, for example, it will be generating a lot and the demand will be low. Then the houses are going to be injecting power into the network. So basically, we're going to see this effect. The voltages in the end of the low voltage feeders are going to be higher than the limits. And then you also can see some congestions in some parts of the network for the assets, cables or transformers. We need to solve this problem in some way, and none of these ways is by DR orchestration. In our case, to orchestrate these DRs, we are using optimal power flow and with a 3-phase version of the formulation that caters for the imbalances of the networks, which is very common on distribution networks. And this is the conventional approach where the houses have measurements of the PV systems and also demand. It sends all this information to the DNSP control room. The DNSP control room will have to calculate this optimal setting points for the DRs, send this information back to the houses, and in this way you can solve the network problems. However, this conventional way is not scalable. Then we are studying a distributed approach where you can break down the networks in smaller problems, and then it's faster to be solved and also can be solved in parallel. And this brings scalability for the problem. Basically, as you can see here on this drawing, is that each low voltage network in our proposal has a local computer that will take care of this area. And when it's going to optimize the problem to find the set points, it only exchange small number of data with the DNSP control room to find the best set points. So this is the way we find to improve scalability. I'm going to show you a case study, again, a high voltage connect to a low voltage distribution networks, where we start with a small system and one high voltage with one low voltage networks. Then we start increasing the size of the problem, which means just adding more low voltage networks to this distribution high voltage network. And we want to see the solution time of both centralized and distributed, and see the trend if there is a tendency of the distributed becoming faster than the centralized. And we are, of course, considering the voltage limits in Victoria, and we are going to do a real-time operation of DRs to avoid these technical issues on the network using distributed optimization for an entire day. So here you can see a customer that I selected to show you that the voltages are within the limits, which are the dotted red lines. Also, you can see that the centralized optimization and the distributed optimization has the same value, so it proves the accuracy of the distributed algorithm. On this plot, I am comparing the solution time of both centralized and distributed approach. The centralized is in orange, the distributed approach is in yellow, and in the green, we made a ratio to facilitate this analysis, which is basically dividing the distributed solution time by the centralized solution time. So it means that when the ratio is higher than 1, the centralized is faster. When it's lower than 1, the distributed is faster. In the x-axis, you see the number of buses, which goes up to 977 buses. On the y-axis on the left, you see the solution time in seconds, and on the right, you see the ratio. If you follow this trend line that we draw here, the dotted one in green, you're gonna see that eventually the distributed approach will become faster than the centralized. So there is this trend, clear trend that it will happen. So the conclusions are that the methods shows potential for scalability, and the distributed optimization was accurate and avoided network voltage issues. And also the real-time operation allows to connect more DR to the network, because now the network is being efficiently used. Thank you very much for your attention. I would like to thank my supervisor, Luis Nando Shoa, and also acknowledge my sponsorships, the University of Melbourne and CAPES.